In this session, we are going to learn how to solve quadratic equations in different methods. So, first, quadratic is taken from the Latin word quadratus, which means second. So in algebra, a quadratic equation is any equation with variables to the second power or second degree, and can be arranged in the standard form, which is ax squared plus bx plus c equals to 0. Let's see what are these. Of course, x is the variable that we are solving the equation for, and I have these terms a, b, and c. All of them are constant coefficients. A is the lead coefficient because it is with x squared, and a mustn't be equals to 0. If it does, if a equals to 0, then this term will be eliminated, and the remaining is bx plus c is a linear equation. So in a quadratic equation, a must be not 0. So the easiest quadratic equation when this term is 0, then I have only ax squared plus c equals to 0. In this case, we can only solve this equation by taking the roots of equation. Then, so first isolate x in one side, x squared in one side, and the constant in the other side. The next step will be just take the square root for both sides, and here we go, solved. Let's take some example on this case. When b, the coefficient b, the coefficient of x equals to 0, then I have only the x squared and the c. I have here x, 2x squared minus 18 equals to 0. The first step is to isolate c. So 2x squared equals to 18. What happened here is I added 18 to the both sides of the equation. So we eliminate this term here, and 2x squared equals to 18. A here is not 1, so I divide by a, both sides. I need only x squared alone. So x squared equals to 9. I need you to take the final step, which is taking the square root for both sides, and here we go. X here equals to plus or minus 3, the square root of 9. This here is x squared minus 3 equals to 13. This is equal, not plus. So I need to isolate c on one side and x squared on the other side of the equation. All I need here, I will add 3 to both sides of equation. Eliminate this term, then x squared equals to 16. Take the square root for both sides, then I will get x equals to plus or minus 4. And that's it. This is the solution of the quadratic equation when b equals to 0. Let's take another method when b doesn't equal to 0, when b is not 0. So I have the equation which is ax squared plus bx plus c equals to 0. In this form, I need another method to solve the equation, which is the zero product property. I need to use the zero product property to find x for this equation. Now, what is zero product property? The zero product property states when I have two terms multiplied to each other, a multiplied to b equals to 0, then either a or b has to be 0. And we use this property in solving this equation after factorization the equation. So let's see the steps to solve the quadratic equation using the zero product properties. First, I have to rewrite the quadratic expression as a product of two factors. So all I need to apply the zero product property, which states if two factors are multiplied to each other equals to 0, then the first one is 0 or the second one is 0. So in this case, I need two factors. So I have to rewrite the equation as a product of two factors. Both of them are linear expressions with term x and constant. So all I need here is to factorizing the term with two factors, then two brackets, two factors. Both of them have x and have a constant. Let's call them n and m. So what is about these constants and how I get these constants? The product of those constants must equals to c, and the sum of the constants equals to b, the middle term. After I did that, I will set each factor equal to 0, then solve both linear equations from the step 2. Let's take some examples. Okay, let's take some examples and apply all the steps using the zero product property. The first example, solve the equation x squared minus 2x minus 3 equals to 0. This is the equation on the form ax squared plus bx plus c equals to 0, where c is minus 3, b is minus 2, and a is 1, the coefficient factor of x squared. So all I need is to rewrite this equation as a product of two factors equals to 0. Each factor has x and a constant here. Okay, both constant, the product of them has to equals minus 3. So I need two numbers, the product of them minus 3, for example, minus 3 plus 1 or plus 3 minus 1. And the sum of these constants must be minus 2. So minus 3 and plus 1. Minus 3 plus 1. Multiplication of these terms will be minus 3, and the sum of this term, minus 3 plus 1, equals to minus 2, the middle term. So this step is check. Now I will set each factor equals to 0 now. The zero product property states that if I have two factors, multiplication of two factors equals to 0, either the first one is 0 or the second one is 0. So I will say if x plus 1 equals to 0, then x equals to minus 1, or x minus 3 equals to 0, then x for sure equals to 3. These are the solution of this quadratic equation. Let's take another example. For example, x squared minus 8 x plus 12 equals to 0. First step is to rewrite this equation as a product of two factors, each one, the product equals to 0, each one has x in it, and a constant. Now, in order to find this constant, I need to say both constant n and m here, the product of the constants must be 12. Okay, we have 12 multiplied by 1, but if I add 12 to 1, it's going to give me 13, not minus 8. So no, this one is rejected. We have 6, 2, and 4, 3. How about trying 4 plus multiplied by 3? Because they have two different signs, then one of them should be minus. Then the product here is minus 12, and the sum will be minus 7. So this one is rejected too. The last choice is 6 multiplied with 2. This gives me 12. Okay, positive 12. How about the sum of 6 plus 2 gives me 8, not minus 8. So I'll give them both a negative sign. So minus 6 multiplied by minus 2 give me 12, and minus 6 minus 2 gives me minus 8, which is the coefficient b, and this is equals to c. So x minus 2 and x minus 6 equals to 0. According to the zero product property, I have two factors, the product of them is 0, so either x minus 2 equals to 0, then x equals to 2, or x minus 6 equals to 0, then x equals to 6. These are the solution of this system, of this quadratic equation. Let's take another example. For example, if I have 2x squared plus 14x plus 24 equals to 0. It's better if we can transform this to x squared plus bx plus c, where a equals to 0. A equals to 1. It's easier in order to find out the constant. So I can here divide over 2 both sides of the equation. I will eliminate this coefficient, so I will have x squared plus 7 x plus 12 equals to 0. So 0 product, then I will have two factor multiplied with each other's equals to 0. Each factor has x in it and a constant. Those constants here, the product has to equal 12. As we discussed previously in the previous example, I have 6 multiplied by 2, 4 multiplied by 3, and 12 multiplied by 1. The suitable one here is the constant that gives me 7 when I add them to each other. So I have 4 and 3, both positive signs, so positive. Then 3 multiplied by 4 gives me C, 12, and 4 plus 3 gives me B, 7. That's okay. Now, either x plus 3 equals to 0 or x plus 4 equals to 0. So in this case, equals will be minus 3, and in this case, equals minus 4. And these are the solution of this quadratic equation.